Welcome to this episode of Robert's Creative Chronicles. So today, I'll be teaching you about nodal analysis. Now, what do we mean by nodal analysis? Nodal analysis is a network reduction technique in electrical engineering that uses nodal voltages as the circuit variables. It analyzes the circuit using KCL and Ohm's law. So we are going to apply KCL and Ohm's law when doing nodal analysis. So in mesh analysis, we used the circuit currents as our variables. Now in this one, we're going to use the circuit voltages as our variables. And after we get the equations, we can solve it using any method we want to find the node voltages. So here are the steps, and here is the circuit. Now the first step is to identify the number of nodes, simple nodes and principal nodes in a given circuit. Now what is a node? A node is any point or junction in a circuit whereby two or more branches are interconnected. Like here is a node, here is a node, here is a node, here, here. All these points, they are nodes. A simple node is the point in a circuit or a junction in a circuit where only two branches are interconnected. When only two branches are interconnected, it is known as a simple node. Like this point is a simple node because only these two branches are interconnected. But when more than two branches are interconnected at a junction, it is known as a principal node. Because like at this point, here there are three branches that are interconnected here at this point 1. So it's a principal node. Here also is a principal node. This base now is also a principal node. It is called the reference node. Because here 1, 2, 3, 4 branches are interconnected here on this line. So among all the nodes, one node is taken as reference node. Generally, bottom is taken as reference node. The potential at the reference node is 0 volts. So this is our reference node in any question you are going to solve using nodal analysis. And the potential is 0 volts. So in the given circuit, there are 3 principal nodes, in which node 3 is the reference node. So these are the 3 principal nodes, 1, 2, and this. And this is our reference node. Then the second step, assign node voltages to all the principal nodes except reference node, and assign branch currents to all branches. So we have to assign all node voltages to all principal nodes. These are the principal nodes, 1, 2, and 3. But it says except reference node. Reference node already has a voltage which is 0 volts. So we assign node voltages here, V1, V2. So you have to assign V1 here and V2 here. This is our first principal node, this is our second principal node. So then, and assign branch currents to all branches. So we have assigned node voltages to all principal nodes. The reference node already have a voltage. So and assign branch currents to all branches. So all these branches, we have to assign branch currents to all of them. So normally, you know that current will flow from this voltage, the positive terminal of this voltage, and enters here. When it comes to this node, it will divide into 2. When it also comes to this node, it will divide into 2. And they all come together and join and enter this negative terminal. So this is our I1. So and here we'll take it as our I2. And here I3, here I4, here I5. So you can actually take here as your R2 and here as your R3. Then this current here will be I3 and here will be I2. So you still get the same answer when solving exercise. Doesn't matter. In case you think that why didn't I say here is I2, here is I3, then here is I5, here is I4. But ideally in a circuit, when current flows from here, it is usually assumed that current will drop here before it enters here. Because here is closer than here. So that is why normally in almost every circuit you see, here will be our first, we'll consider here before considering here. Because current will You see the space. Before it enters here, it must drop here. It cannot just enter here without dropping here. So that means here is actually right to be taken as I2. And here, here, the last place current to enter is here. It's best to even do it like this. Don't take here as R2, don't take here as I, just do it like this. It's best here. Then assign node voltages. The second step, okay, we have done this. Then the third step, apply KCL to those principal nodes for nodal equations. And by using Ohm's law, express the node voltages in terms of branch current. So we're going to assign KCL to all the principal nodes. So applying KCL to principal node 1, we have I1 equals to I2 plus I3. So see I1 equals to I2 plus I3. So we have applied KCL to this node 1. KCL states that the algebraic sum of all incoming currents that enters a node is equal to the algebraic sum of all outgoing currents that leaves that node. So this is our node that we're considering. I1 enters this node. So I2 and I3 are leaving it. So I1 will be equal to the sum of I2 plus I3. That's how we got it. I1 is equal to I2 plus I3. Then the second node, okay, though, let's finish this. So then, using Ohm's law, we get, so you apply Ohm's law to this I1 in this circuit now. I1. To get I1 using Ohm's law, I is voltage over current. Current I is voltage over resistance according to Ohm's law. So to get this I1, current flows from higher to lower potential. So the current flowing from I1 will flow from V to V1. That means V is at a higher potential than V1. So this one will be positive, this one will be negative. So it will be the voltage across this resistor R1 is V minus V1. Since current moves from higher to lower potential, in this case is V to V1 respectively. So it is V minus V1 divided by R1. You see V minus V1 divided by R1. Now I2 in the same way, current will flow from higher, which is V1, to lower potential, which is 0 volt. So it will be V1 minus 0 over R2. V1 minus 0 over R2. So over R2. Then the third one, I3. I3 now is V1 minus V2 over R3. V1 minus V2 over R3. That's all. Then we simplify this equation and we get it. Then the second node, the second principal node, no matter how many principal nodes there are, you have to apply this KCL to all of them and Ohm's law. This KCL and Ohm's law to all of them, and then you solve them in simultaneous equations. So then the second one, I3 equals to I4 plus I5. So this is I3 equals to I4 plus I5. Now I3 is what? V1 minus V2 over R3. V1 minus V2 over R3. So this one is KCL, this one is Ohm's law. Then I4 is what? I4 is V2 minus 0 over R4. V2 minus 0 over R4. So then I5 is what? I5 is what? I5 is V2 minus 0 over R5. So this is V2 minus 0 over R5. So the logic of this thing, of finding the voltage, you find the resistor. Let's move to the side. You find the resistor. This current I3 is moving from a higher potential V1 to a lower potential V2. So you take the higher one minus the lower one, the lower potential one, and then you divide by the resistance between them. So you do this in all these branches. The higher voltage minus the lower voltage divided by the resistance. And the current, you know it from the direction of the current. Then the fourth and final step, you solve the above nodal equations to get the node voltages. You solve these two simultaneous equations. Using any method you want, you can use elimination method, substitution method, Cramer's rule, anyone to find your node voltages. So that's all about nodal analysis. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.